Hello, this is Mrs. Huntley. This is the second video in the Pythagorean theorem. You should be in the supplemental packet, the packet of materials with the supplemental materials. At the top of the page, it says Pythagorean Theorem Day 3 3D Notebook. That's the page that you should be on here. And the essential question is already written in for you. How do I change the Pythagorean theorem when working with a 3D figure? And this little symbol here stands for sum or summary. This is the Greek symbol for sum. So the way these notes were set up is your essential question is here, and then you could summarize the lesson here. Now that's a pretty tiny spot for a summary, so you're going to have to you're going to have to write small in order to fit it all in there. So the warm-up before we get going. What is the Pythagorean theorem and what is the converse of the Pythagorean theorem? What I would like you to do is actually pause the video and go back into the notes from the last lesson and see what is the Pythagorean theorem. Remind yourself of it, write it down. Same thing with the converse, and then unpause the video and come back and see if you were right. So please pause the video right now and do that for me. Okay, the Pythagorean theorem. If a triangle is a right triangle, then a squared plus b squared is going to equal c squared. In other words, I take the length of the side and square it, the length of the other side and square it, and that will equal the length of the hypotenuse squared. If I'm missing one of those measures, I can use the Pythagorean theorem to help me solve if I know already it's a right triangle. The converse of the right triangle, if a squared plus b squared equals c squared, then the triangle must be a right triangle. So that's like when I don't know if it's a right triangle or not, but I have all of the side lengths. Then I can use those side lengths to plug it into the a squared plus b squared equals c squared formula to see if it is a right triangle or if it is not a right triangle. So let's move on with today's lesson then. 3D. We're talking about 3D shapes here. What does 3D mean? It's three-dimensional. So it's a three-dimensional figure like a cube or a rectangular prism. What is a rectangular prism? It's like a box. So it has space inside of it. It's a three-dimensional shape. Diagonal in a three-dimensional figure, what does that mean? It's like cutting the box from the top right corner to the bottom left corner, or vice versa. It could be the top left to the bottom right, or the front of the top of the front of the box to the bottom of the back of the box. However, it would go from like one corner of the box to the other corner of the box. And here's some examples. And I know you don't have these examples in your notes, but that's okay. You can try to copy them if you want to, but this is just for explaining purposes. So we've got our height of the box, we have our length of the box, we have our width of the box, and then here this diagonal is going from the top corner on the left to the bottom corner in the back of the right. So it's going right through the center of the box. Hopefully you remember, if we're trying to find the volume of this entire box, we would take the length times the width times the height, and that would tell us the entire volume of the box. We're going to adjust our Pythagorean theorem to be able to give us the diagonal of the box instead of just the diagonal of a triangle. Actually, the reason I'm using this other, this looks like a kind of like a cube, except it's too tall, so I guess it is a rectangular prism. But this shows you pretty clearly that there is a right triangle going across the diagonal of the base of the box, going the height of the box, and then this going from the top back corner to the bottom front corner would be our diagonal going through the center of the box. So you can see kind of that there's that right triangle in there. And we just have to adjust our Pythagorean theorem so that we can figure out this diagonal of this right triangle that's being formed in this three-dimensional shape. So that's what we're going to do. Now we have a length of 4 here. We've got this 3 over here, and it's 12 units tall. We don't know what our units are. This is just kind of a drawing that is very generic. So we're going to adjust our Pythagorean theorem. Instead of a squared plus b squared equals c squared, we're going to add that dimension. So we're going to have a squared plus b squared plus c squared equals d squared. What? So we're going to plug in the values that we know. Our A, B, and C are pretty much interchangeable here. So I'm going to say 3 squared plus 4 squared plus 12 squared equals D squared. And we don't know what D squared is. That's the unknown that we're looking for. So 3 squared, you should know by heart, I hope, 9. 4 squared is 16. 12 squared, if you don't know it by heart, you should be trying to memorize all of your perfect squares up to, I would say, at least 15, and that equals D squared. So let's now add 9 plus 16 plus 144, and that equals 169. Hopefully you might even recognize 169 right now. I'm not sure if you do. We don't want D squared, we just want the length of D. So I'm going to take the square root of D and the square root of 169, because whatever I do to one side of the equation, I've got to make sure that I do to the other side of the equation. And again, if you didn't memorize it already, hopefully you're working on memorizing your perfect squares. And the square root of 169 is indeed a perfect square of 13. So the measurement of the diagonal of this cube is 13 units. Let's go ahead and practice a few more together. So here we've got a length of 12, a width of 3, a height of 4. They're saying that these are centimeters. You know, I'm going to ask you to keep your notes kind of on the left side of this drawing and kind of like close to the drawing, because I'm going to need the right side of this paper to add some notes in that you don't have. So please try to do that for me. So I'm going to write our formula. A squared plus B squared plus C squared equals D squared. Okay, so again, our legs are pretty much interchangeable, but I'm going to stick with having my C be the longest one, just because my brain is trained that the C squared should be the longest one that I have. That's a given. So I've got 4 squared plus 3 squared plus 12 squared equals D squared. Oh, is that the same dimensions? I think that's the same dimensions. Oh, well, we'll work it out again. 4 squared is 16, 3 squared is 9, and 12 squared is 144. It is. So when I add 16 plus 9 plus 144, I get 169. Going to take the square root of both sides, and D is going to equal 13. So this would be 13 centimeters. I didn't realize it was the same as the example that I added on the other page. Sorry about that, but hopefully, you know, the second time through was even easier. Now we have a cube with a side length of 3. What do we know about cubes? All of the side lengths of cubes are the same. So if that's 3 feet, this is going to be 3 feet, and this is going to be 3 feet. I just wrote another 3. It's late in the day. Okay, A squared plus B squared plus C squared equals D squared. So 3 squared plus 3 squared plus 3 squared equals D squared. 9 plus 9 plus 9 equals D squared. Take the square root, take the square root. The square root of 27 is not an even number, so D is going to equal 5.196, and it goes on. I'm going to round to the nearest tenth, so I'm going to say that this is 5.2 feet going across that diagonal. Hopefully that makes sense to you. Okay, what is not included in your notes, and I want you to include it right here. You have grid paper behind your notes. I don't have grid paper on mine, but I'm going to switch slides, and I'm going to have a piece of grid paper here. What I'd like you to do is create a coordinate plane, just it's a positive plane, so you don't have to do it as big as mine, but go up, make a point at, make an x-axis. I can't speak very well. Make an x-axis that's at least 8 units long. So from 0 to 8, you're going to draw a line here. and then make the y-axis going up at least, let's say, 6 units tall and coming down to 0. So if I were to draw this, if I had a piece of plain grid paper, I would just be drawing, like here's my y-axis and here's my x-axis. This would be 0, 0, and then I'd want to count however many lines going to the right. So I want at least 7. So there's 1, 2, 3, 4, 5, 6, 7. And then going up, let's go up at least 5. 1, 2, 3, 4, 5. So if I had grid paper, like you should have grid paper, you're making the lines darker to create your x and your y axis. What I'd like you to do now is make a point at x equals 2, y equals 4. So come over to 2 and then go up 4. 1, 2, 3, 4. You're making a point there. And then at 6, 1. So 1, 2, 3, 4, 5, 6, and then up 1. So you're drawing it, and I'm trying to demonstrate how to draw this diagonal because mine's already drawn for me. So that's what I would be creating on my paper. Now, if you remember, when we were doing the similarity unit, I was saying you can't count the diagonal units. When we had to count like units to figure out how large something was, I was saying the diagonals, you can't just count them. Like this is probably greater than 1. This one's less than 1 because it's just that little corner there. This one's just that little corner there. So you can't count them going across the units the way we might if they were going across full units. So how do we figure out the length of a diagonal? Well, now that we know the Pythagorean theorem, what we can do is create a triangle, and then I have my side lengths. This one is 1, 2, 3 units, and this one is 1, 2, 3, 4 units. So now I can use the Pythagorean theorem to figure out the length of that diagonal. So I'm going to say a squared plus b squared equals c squared. Now this isn't a three-dimensional shape. This is just a flat shape, but we're in the coordinate plane and it's going across diagonally, so I can use my regular old Pythagorean theorem. So a squared is 3 squared plus 4 squared equals that c squared side. So 9 plus 16 equals c squared. 9 plus 16 is 25. So take the square root of 25, and c is going to equal 5. So this diagonal in the coordinate plane would be a 5. See how it wouldn't have worked if we tried to count the units? Because this looks like 1, part of 2, part of 3, part of 4, part of... It just doesn't work. Okay, here's one that's just going negative and it's a little bit longer. So try to recreate, if you've got enough room on this piece of grid paper or if you need a separate piece of grid paper. But I'm going to go ahead and demonstrate this for you again. And again, I've got a diagonal going through the coordinate plane. I can't count units on that, so I've got to create a right triangle. So when I do that, I'm going down 1, 2, 3, 4, 5, 6, 7 units. So that's 7. And then I've got 1, 2, 3, 4, 5, 6 units on this side. So this is 6 units. I'm going to erase those numbers. I just wanted you, when I'm creating the video and I'm counting things, sometimes people are confused as far as what I'm counting. So this will be my right angle. Whoops, I got to switch back to a pen. There we go. This is my right angle. That's my hypotenuse. So a squared plus b squared equals c squared. 7 squared plus 6 squared equals c squared. 7 squared is 49. 6 squared is 36. Add together 49 plus 36. Whoops, turn the calculator on. 49 plus 36 is 85. Take the square root of both sides of the equation. The square root of 85 is 9.219, so c equals 9.21. If I'm rounding it to the nearest tenth, that would be 9.2 units. Okay, so if I'm trying to find the diagonal in a coordinate plane, I'm using the plain old Pythagorean theorem. I've got to create legs, create a right triangle by connecting the two ends of my diagonal at a right angle in the coordinate plane, and then I use a squared plus b squared equals c squared. If I'm finding the diagonal of a rectangular prism, I'm going to take a squared plus b squared plus c squared to equal the diagonal. So hopefully that makes sense. I actually covered two different things today, but you should be able to summarize how do I change the Pythagorean theorem when working with a 3D figure, three-dimensional figure, and you should be able to summarize that right here. So please go ahead and do that before you come to class tomorrow, and I hope you have an awesome night, and I'll see you tomorrow. Bye.